Okay, so now that we can sort of understand how, the theory anyway, that we could get layers of the Earth imaged by seismic data, how are we going to get a big enough boom to be able to transmit energy through the entire Earth? Last time we checked, the Earth is about 8,000 miles from the North Pole to the South Pole, or any other place from one side to the other. And to get any energy to travel through the whole thing would have to be a lot. There's not very often that something like that happens, at least not very often for science. In the top right here, we have an image of what could very well be the Hiroshima atomic bomb. And this, of course, is an immense amount of energy release, possibly the largest energy release due to man. We don't like to fire those off very often, so what else can we use to study the Earth's interior? Well, we can wait for nature to do it for us. In the bottom left-hand corner, this is a photo of some of the destruction that was caused by the Nepal earthquake in Kathmandu on May 4th, 2015. You can see that several buildings have collapsed. There's generally a lot of rubble, and you guys have probably heard of other instances where earthquakes have caused a great deal of destruction. This particular earthquake killed about 9,000 people and displaced tens of thousands more. It registered on the earthquake scale, the Richter scale, as a magnitude 8 earthquake. Well, how much power is in a magnitude earthquake of 8? Well, about 500 times more powerful than the Hiroshima atomic bomb is how much. You can go and check that for yourself at this link at alabamaquake.com /energy. It's got a really interesting comparison between things that you are familiar with and how it compares to earthquake magnitudes. So you might want to go check that out. But certainly the amount of energy, 500 times the amount of energy released by an atomic bomb, that amount of energy you should be able to believe is enough to travel through the dense Earth and come out on the other side. So if we have seismic stations that are recording all over the world, then we are able to record the seismic waves that are intercepted after this earthquake has gone off. So let's take a close look at those seismic waves and see how we can deduce the material characteristics of the Earth from seismic data.